This is working. All right, so we'll kick off with this while we Miteco, Miteco, Miteco. That's what you say when you have a technical problem. It's like Beetlejuice, Beetlejuice, Beetlejuice. How about this one? Is this one working? Yeah. All right. So if we have to, we can make do. So we're a few minutes late starting. I had to install an HDMI adapter and a new driver and reset my whole system. So everything I queued up to show you, I'm now going to have to open during the session. Isn't that fun? So I'm Al Morton, co-chair of the Benchmarking Methodology Working Group, and this is
Sarah Banks, co-chair of. Thank you.
So welcome to our session at IETF 100. This group is, we were overlooked in the mentioning last night, but this group is as old, chartered-wise, as the DHC, Dynamic Host Control Working Group. I think they've met one more time than BMWG, but they were both chartered at the same time. So we have that honor, and that's why I didn't want to miss this one for sure. Okay, so we've done the introductions. You've all moved relatively close to the front. Thank you for doing that. And if you're not subscribed to the BMWG mailing list, that's how you do it. Okay. So note well. It's now Thursday afternoon. You should have seen this about 40 times. But IPR is important here. You have to disclose it. I don't have the most up-to-date slide, unfortunately. But there is an update to 5378, I think, that basically changes a few things IPR-wise. So please take a look at that. I mean, you've basically had the chance to do that in your registration and everything. Okay, so here's our proposed agenda. We have a note taker, Sarah? It's Neville? Oh. we might very well, yes. So
usually traditionally, when folks don't move to the front, we make the person sitting in the back, which is the furthest person in the back, take a minute.
Welcome to the work group. And you're, yes, okay, good, thank you. Before we get going here, we've circulated the blue sheets, and I think almost everyone has signed it. Anyone not signed the blue sheets? No? Okay. Sarah is going to monitor Jabber, so if there's any Jabber activity, we'll pick it up there. We've talked about IPR. We should also mention Miteco. We have one of our presenters, Sean Wu, on Miteco there, and one other participant, Mr. Ding, I think it is. It's a little hard to see, for me at least. So we'll be watching for participants to queue up. And in any case, so this is the agenda. We'll quickly do working group status and talk about our charter and milestones. We've got one draft still in, actually two drafts on SDN controller performance. They're in working group last call finishing up. And one draft that we've pseudo-adopted on EVPN and PBB EVPN benchmarking. That's actually two topics that were combined. And I guess we'll get a status and a little bit of discussion about that today. Mostly from us, though, right? The chairs, yes. Yeah. So then we have a series of new proposals. Our remote presenter, Sean Wu, will be talking about the network service layer abstract model. We have updates for the back-to-back frame benchmark, which is part of RFC 2544. Please find and sign the blue sheet, sir. Thank you. And then we'll have a fairly brief discussion of the updated benchmarking for modern firewalls kind of proposal, which really was just described for the first time on the list today. We've known it was coming, but it came a little slower than we thought. So at least we have something to look at there. But then, after looking at these new proposals and reviewing the old ones briefly, we'll look at the rechartering text. We'll consider what might want to modify additionally, and then we may look at a few milestones if we've got the wherewithal to do that. And I actually think Warren will join us today, Sarah, our AD advisor. He said he had another meeting, but I think that other meeting was canceled. I think it was DNSSEC. Yeah, so he may well be able to join us. Any changes or bashes to the agenda? Seeing none, that's good. Sir, please grab the blue sheet there and sign in. You'll see I'm recruiting blue sheet signers because we're late on Thursday afternoon, and that usually affects attendance. The only thing that would be worse would be to be after lunch tomorrow, I think. So in any case, I'm sorry. Good question. Sarah asks, how many newcomers do we have in the room? Please raise your hands. Wow, 5. Very good. So what I always say when newcomers join us, and you're very welcome to join us, this is a very easy group to join. If you have a testing background, you'll fit right in here. And we have a supplemental web page, which Sarah was nice enough to restore to the interwebs, which in a few paragraphs tells you how to get involved here very quickly. So that's on our data tracker charter page.
So you guys will see at the end, we're talking about proposals and rechartering discussion. What that really means is, as we're looking at taking on new work, you guys are joining at a perfect time, because if there's something you guys are interested in and you wanted to bring in, now's a great time. So I realize you're new, or maybe on a Thursday, you're 4 days into your first IETF. So if you have questions about that, let us know. But now, please don't be shy at the end when we get to that. Make sure if you have ideas, let's hear about them. And Al and I can help you even after the meeting on what next steps are and how to bring that work in and what have you.
And there's a new attendee who's joined us. Please grab the blue sheet, sir, which is and pass it back there. Perfect. Thank you so much. Okay. So other than this, what we just talked about, no bashing of the agenda. Seeing none, let's move on. All right. So here's our quick working group status, folks. I'll bet this thing is supposed to be turned on. We went through a whole IPPM meeting. And that's got to be it, right? Wow. Okay. Right. Usually you can turn them on, though. Anyway, so MeTecho. We've got a microphone out, and we've got a speaker monitor which is not turned on. They're supposed to be monitoring audio to pick this up. I mean that we could do that too, but I can't. So here's the quick working group status. As I said, working group last call is just about to end for the SDN controller drafts. We're tracking many proposals. Here's a list of some of the proposals which we've just talked about in the agenda. But we've got more status. Some really good news here. Look at the list of 4 RFCs that we've completed in the last interim period. So the reason we're rechartering is fairly obvious. We've actually been really productive in the last couple of years or so. And believe me, this is a group that works long and hard on its RFCs. To push out 4 like this is pretty amazing. I can't remember this ever happening in a long time. Right. So discussion on the agenda. We're going to be talking about the charter. We mentioned that. Oh, and here's the link to the supplementary BMWG page. I knew it was in here someplace. This is on encrypted.net, and Sarah was kind enough to provide this after one of the cable providers discontinued my residential web pages. So no problem for that. Here's our current milestones. Just one left on the current charter. And that's also a good state to be in. It means that we should be considering proposals and looking at rechartering. So we're a little bit late with that one, but we're not going to worry about it. Not your fault. So when our drafts are reviewed by other areas, and it's a good chance to mention our scope and charter here, we do all of our testing in an isolated test environment. Packets that we use, frames that we use, they all have addresses in an address space that's been assigned to the benchmarking methodology working group. And what that means is that if you see these packets on the live network, you can discard them. We don't want our packets to get out on the live network, and we prefer the testing to be isolated. So that's one way to to try to ensure that kind of isolation, have our own address space and so forth. But the main point I'm making here is that what we want is for the security folks to understand if they pick our draft up cold and they haven't read our charter, they may look at this and scream, what do you mean you're doing? Look at all this traffic you're sending into the network. That's got to be some kind of problem. Well, it really isn't. It's not going into the network. It's a laboratory, isolated test environment. So we remind them of that in general, and this should be part of all our drafts. Let's see. I think maybe this goes too far here. Yeah. I think that's. Well, let me check. Ooh. Yeah. So we'll look at the proposal summaries. I guess we can look at this now. So we've adopted in some way, shape, or form this EVPN benchmarking proposal. So we've got that all in green there, and you can see the kinds of things that we evaluate. Whether there's a proposal written up for it, whether it's in the scope of the charter, we make the call on that ourselves. And then get feedback from our AD, whether there's a draft that supports the proposal, whether we've seen significant support at meetings and on the list, and whether there's any dependencies and other notes. So everything here we have covered for that, and we've had the adoption call on the list, and I believe that was successful. And so the last thing we need there is a version of it that actually takes on the working group file name, but that's something we'll be working toward. Okay, so there's other proposals here that I'll just briefly mention. This virtual benchmarking as a service. We haven't seen much on that in a while, and we kind of alerted one of the authors to it and at the last meeting, and he said, oh yeah, I'm going to bring something in. Well, nothing. So that may well be dead. The virtualized platforms testing, this was discussed quite a bit in Chicago, but we haven't seen any activity on it since. Nevertheless, we've got a draft dated this year, so I think we'll keep that on the matrix for a while here. For service function chaining, we did see something on that in July at the last meeting. And for virtualized network, which sort of went on hiatus for a while and then came back, we've seen a new draft of that in July, but it continues to have the issues that have been raised on the list and at meetings. So they really haven't solved the problems despite keeping the draft up to date. So that's kind of a liability there. I'll mention that we've got the new proposal from Sean Wu, going to talk a little bit later, about the network service abstract model, and then a new proposal from me on back-to-back frame benchmarking. And then this other one on modern firewalls, next generation firewalls. So, but that came in so late, it didn't end up in the matrix. All right, so that's what we'll get to later with the rechartering discussion. Any questions about the working group status? Okay. All right. So then let's proceed. Let's proceed to our. Now, I guess the best thing to do is proceed to our web page here. This is going to be horrible. Wow. Okay. So, which one would you like me to bring up?
I mean, I guess you could bring up the draft. And you could put the-
That's what I
at
mean.
the end of the line, so-
It's meth or
We'll do mine for, we'll do STN controller first and then EVPN second. How about that? I think I give you a page for both.
yeah.
Okay. So as Al mentioned, the SDN controller draft is in the hopefully working group last call. Comments welcome. We're just about done, and Al, I saw feedback from you, I think yesterday, where you caught a snafu on the editing side with a cut and paste error, and then an additional comment that I need to work through with my co-authors. So we'll do that and revise and resubmit. But again, it is working group last call. You guys are new, so please, if you have comments on it, now is the time. Now's the only time you're going to get to comment on that particular draft. But
Yeah, we got a dead mic there as well as.
Oh, bugger.
Great. Where did you press the button?
He did it to the left, not to the right, which is what you hit. I think. I thought.
I thought.
Thank you.
Yeah. Great. Okay.
Thank you, sir.
Good. Thank you.
Any questions on the SDN controller draft? Alrighty then. Shall we move on to the EVPN PBB draft?
Yeah.
So the author there is Sudhin Jacob. He's been coming to the IETF meetings. He's based out of India and couldn't make it to this meeting this time. I don't see him logged into the Meet Echo either. So he brought the draft in last meeting. There was a fair amount of, I would say, spirited discussion in the room about the technical and the editorial content of the draft. We do typically, I would say we almost always ask that we have discussions on the list, but because there's been a huge outreach, I think, with the IETF India community and making sure that folks are comfortable, I did discuss with Sudhin offline and pointed him back to the minutes from IETF 99 where the content, some technical things, for example, his test bed wasn't very clear what he was testing at all. And while he could verbally, or I think he was verbally trying to explain it, the document needs to typically read if he's not here. So what I've asked him to do as a co-chair is to go back and review the IETF 99 minutes and address the technical commentary. And if he can do that, then I will help him as an editor, from an editorial function. I will help him with the English or just the editing. Sometimes doing your first draft can be daunting, so we are here to help. We've all been in this position before. Well, I don't know if you ever were. I feel like you might have come in knowing how to do it all, but I certainly did not know how to do it all when I first joined, and Al was a huge help. So we're here to help, especially when you're new doing it the first time. We realize it can be a challenge.
Actually, my first draft looked like the dog's dinner.
Oh.
I was using a Word template, and I ran a special thing on the template, which you were supposed to, some little script, supposed to fix the carriage return line feeds into something else, and it actually deleted all the white space, ran the whole thing together. And I looked at it and said, well, I guess there must be some additional processing at IETF where they fix it up. So I submitted it that way. And then I asked Matt Mathis about it, and he said, oh, no, they don't do anything. So the first one was a true nightmare. And it didn't take me too long to ditch the Word template. But yeah, that's actually good advice. So anyway, but that's an old story, like 1998 or something.
Don't be scared of the word template. As the non-engineer at IETF, I know it's not common to say that out loud, but I live and die by the word template. So,
Well,
well,
it's very good work. Joe Touch put that together, and I guess it keeps it up to date. So that's great.
so from here, I'm expecting, I will ping Sudin if you want to assign me that action after IETF 100 to make sure that he understands that we've adopted the draft, that we do see the value, and not to be discouraged by the amount of feedback that he got, because it was a fair amount of feedback, but I think the draft will be much better for it. And then once that comes in, I'll ask him to post that explicitly on the BMWG list. And if you're interested, if you have experience here, please read the draft. And then likewise, I'll preempt Al before he gets to say it. When you read somebody else's draft, well, the onus is there that they'll read yours, and that's a good thing. Getting multiple eyes on a draft is a good thing. So
that's right. And that's how you join the group, really, is by reading a few drafts that we're working on and providing your expertise in form of comments. Where's the blue sheets? All the way in the back. There's a blue sheet coming toward you, sir. Please sign it. Thank you. Great. Thank you. All right. One further point on this, Sarah, and that is, I seem to remember that Sudin was looking for additional editor help. I think you've volunteered to do that. If there's anyone else who has EVPN expertise, we should also consider maybe another author as well to provide real, the technical background that might help out here.
yeah, I think that's ultimately a question for Sudin, because at the end of the day, he needs to either take on that help. I think the feedback he got from your colleague, whose name I forget,
Jim Utaro.
Jim, thank you.
From AT&T.
Yeah, was very valid. I also think it might not have been received as
Well,
easily, but
as long as we captured it and someone can implement it with expertise that's needed, then and really now that we've adopted this as a working group draft, we're sort of in charge of the editor list.
yeah, for sure. So I think doing something that I've seen us do in BMWG, well, under you even before I was chair, getting that cross working group feedback is probably going to be key here.
Yeah.
Because we aren't going to get, unless we have Jim in here every single time, I think we're going to have to take it to the routing area to get a review.
Oh, yeah.
Which is good. So we
That's
can
right.
do that as well, or do that early,
Right.
so he gets some time to turn around the feedback.
Yeah, that's we'll work this at a pace that everybody is comfortable with. Very good. Okay, so it's fairly easy to find our drafts on. This is the tools page, by the way, which this has been around a lot longer than the data tracker, and I'm kind of more comfortable using this. But there is, of course, the data tracker version of this, and you can go there. All right, so let's see, where are we in the agenda? All right, we're racing along here. Okay, so Sean, can you hear us, and can we get you in the queue for speaking?
Yes. Hi, Al. Can you hear me okay?
Yes, we can hear you perfectly, Sean. That's fantastic.
Great. Well, I didn't
So I'm
realize that we move so fast. It's almost my turn.
Yeah. Well, I guess that's a good thing, because we lose our note taker at 5 o'clock local time. Oh goodness. All right. So hang on a second here. I'm finding your slides on my greatly reduced screen. All right. So I've got your slides up, Sean. I suppose you've got a remote display there?
Yes, I do.
Great. Okay. Well, Well, first off, welcome to the working group, and this is Sean is yet another new participant, but he's come to join us with some knowledge of what we're doing, and also a pretty good proposal in hand. So let's have a look. What just happened there? No signal. Okay, now we're back. That's obviously pretty hinky. Okay, you can go ahead anytime, Sean.
All right, thank you. Hello, everyone. I'm Sean Wu from the Juniper Networks. Actually, the previous author, Sadine, is also from Juniper, and I actually worked with him in the past on the EVPN as well. So let's move on to the next slide.
Yeah, I'm doing it, but I just got to watch out what I touch here.
All right, thank you. So the network services layer abstract model is really a reference model that provides kind of a skeleton of how we would define and document the benchmarking methodology based on the EM data structure. So I have read quite a few past RFCs and a draft from BMWG, and the first question is, do we need another modeling, or do we need another methodology in general, since we have already many existing standards out there? So let's take a step back and consider our traditional methodology for the benchmarking. I think Al mentioned it before, is that we typically looking at the black box level testing, and we're looking for the external characteristics of a device or a system. So there's a few challenges as the networking technologies have evolved over the years. For example, we're looking at the more black network testing. Instead of testing focus on a single device or a set of devices, in many cases that the user will be presented with a private virtual cloud. How do we do it? So we're looking at external characteristics of a network rather than a device or a set of devices. The EM model has made a significant progress over the last couple of years, and the direction of the EM model and what we are doing here is complement, but on two different directions. What EM model has been typically doing is trying to define almost every aspect of a technology or protocol, how the controller can use a vendor agnostic way to configure a device using a set of the very detailed commands. But here, the abstract model is trying to use a similar set of the syntaxes, but only retain the high level, which is relevant from a service outlook perspective. So that will leave a lot of details out, only focus what are the external characteristics. Another kind of buzzword is intent-based networking. I'm not sure how you already are familiar with the intent-based networking. So traditionally, a user interact with the device via a set of configuration, and the EM model is just a vendor-agnostic way to do it. But we have evolved using the SDN controller that it will only require user to provide a very small subset of the necessary intention, so that based on a lot of the machine learning and the telemetry data, the SDN controller will automatically provision the services using a set of the growing number of the underlying devices. So we no longer have a static set of the configuration. Instead, we will actually benchmarking the intent rather than a set of the devices with a concrete configuration. Another challenge is the scale and dimension. The unit dimensional scaling and unidimensional benchmarking is often the primary focus of testing. And typically it works great when it's in the unit dimension, the ones adding the additional dimensions, which is the multi-services edge in many different cases. That's where we start to see the problem. So we need to have the ability to abstract the multi-dimensional networking and into a simplified model so that we can really test it out in the lab. And finally, the convergent services and has really blurred the boundaries between the different layers. Today, like if we want to send the layer 3 traffic, we do not necessarily require a layer 3 interconnect or layer 3 based protocols. In many different cases, for example, the EVPN with type 5 route, it can actually not only exchange the layer 2 MAC database or MAC route, but also has the ability to exchange the layer 3, the IPv4, IPv6 routes. So the boundary of layer 2 and layer 3 is kind of intertwined these days. So using this service model, we're trying to come up with separate the underlying technology and the service profile, which basically is a set of the customer requirements from a business perspective. So this is why we are trying to propose a simplified EM model for the model network services for the benchmarking purpose. Next slide, please. So a little bit busy slide here, or I should have put a box in the middle. This is there's 4 key components in this model. Some of the old existing that we have been using for decades. Some of the top component is relatively new. So let's start from the bottom. If you look at in the middle column, so the bottom is the inventory. The inventory refers to a set of the nodes or hardware software resources, and using a bunch of the connections, wired or wireless, they form a physical topology. That is the underlying hardware layer that we are dealing with. And moving up a little bit, I separated the logical topology from the physical topology. The reason being, using the same set of the physical topology in a lot of the benchmark testing, and we can easily create the tunnels to form a completely different view of the topology, and you have the protocol adjacency with the devices far apart from a physical perspective, but they are really next to each other in the logical perspective. We can use some of the tunnel technology like VXLAN, MPLS tunnels, LSPs, the GIE tunnel. Those are the technology can really change the perception of the higher application, how they view the underlying physical topology. The service provision, which is in dark blue bars, those really the static configuration of a testbed. If you're looking at the infrastructure, this is focusing on IGP, BGP, the MPLS transport, and potentially the bridging. Those define a set of the communication protocols between the networking devices, provide the baseline connectivity. And finally, on the top, on the left side, which is the service layer, this is defined a set of the ultimate services received by the user perspective. We have the internet exchange provider, we have a data center, metro Ethernet, and so on and forth. So on the left side of the 5 different layers, those are not new, and we have been using for decades, trying to capture that in the inventory and the service provisioning. But what's new here is to use a set of the EM-based data modeling to describe or document those key elements and to provide the baseline support if we try to zoom in a particular service benchmark. So next 2 boxes, one in the dark green, it's a service profile. I think a lot of times in the YAM model, we typically define the configuration, which is a static scale, static configuration. The service profile is more referring to a set of the dynamic elements of the network. There's 4 subcategories, and the traffic emulation, those are not new, and typically a test vendor, they will come of the traffic profile, the protocol emulation to exchange the control plane data with the network under test. What's new is, in addition, that a 2 subcategory was introduced. One, we have to have a certain set of the SLA, or how to describe the resiliency of a network using a set of the timers, like how quickly the network will respond to a failure scenario. And finally, we need to a set of the events that will need to define a common event, like no link failure, the control protocol churns, and some of the mobility. The mobility could be a station moving from one location to another, or VM motion that where we quickly reprovisioning a virtual machine from one data center to another. So those are the 4 categories that we are looking to define what a service profile. Service profile is really owned by a customer, versus a service provision is owned by the provider, an ISP or cloud provider. And finally, on the top is the resource utilization. The resources describe how much, it's a health indicator of the network. Under a particular provision, which is a set of the static configuration, and a particular set of the load, which is described in the service profile, and how busy the network is. Do they have enough capacity to handle additional load, those things. Okay, let's move on to the next slide. But if any question from the room, and feel free to stop me, and I will definitely want to answer if you have any doubts or questions that need more clarifications. So here's the okay. Yeah.
Sure thing, Sean.
Okay. Here's the set of the design principles that we're trying to come up with this service model. One is we're trying to leverage the existing YAM model. I took a look of the tools, IETF tool, or data tracker. There are tons of the efforts and ongoing or past. There are 25 YAM-related RFCs, and more than 100 internet draft is being actively worked on. So we did not want to reinvent the wheel. We want to take the existing, what the work has been done in various protocol areas. But we don't want to take all. That's what we want, making sure only provide a sufficient set of the keywords to this abstract model, but not exhaustive. We will leave a lot of details out. For example, the IP addressing and route distinguisher, and those are necessary for a real production network provisioning, but not needed here. We are trying to look at the aggregated view from a network high level, not necessarily zoom in down to the device level. An additional set of the rules we have to introduce is the distribution model. We're not trying to mirror the exact how the network is operating, but instead we're trying to look for abstract the distribution model to use a very few parameters to model the existing set of the routing entries or MAC database or tracker profile. And the service model also need to provide the view from different perspective. The customer, the provider, and the manufacturer, they have different focus of how they need to benchmark. For example, the customer is only looking at the network capability, not necessarily care about the underlying technology. They provide the service profile meaning that I just want to move the traffic from place A to place B. They don't necessarily care about which vendor of the equipment, what technology you use, EVPN or VPOS. They probably don't care. The MVPN or just vanilla IP multicast, those are just a choice from the provider perspective, but not necessarily from the customer. So the service model is really focusing on the external characteristics, which is from a set of the service profiles. And finally, but not least, is we want to make sure those service models will accommodate the new requirements from the VNF. There's a lot of the discussions, as Al mentioned in the agenda, that the SDN, the virtualized platform, and those need to be taken into consideration, not only the virtualized platform, but also virtualized network. So, okay, well, let's take a look at the example in the next slide. Again, there's a lot of the data, and I'm not sure if you can see it clearly from the behind. So this is not a complete profile. It's a subset of the model that is broken into 4 different categories. On the top, there are 3. One is the service definition. Here is an example of the layer 2 services. In the middle is the traffic profiles. Traffic profiles are really, you can consider as a service profile. What really the customer is going to put a load, what kind of a load is put on to the network that is going to be handled by the underlying service. And on the right side is the resource, because when we do the benchmarking, and we have to look at the not only the final throughput, but also looking at the health indication about the network. Again, this probably is not the black box testing, and we will have to look at the performance indication, looking at those KPIs of the devices. And on the bottom is the resiliency. The resiliency is really define a set of the timers, define how quickly the network or the device will recover from itself. These are some of the common events. For example, the failover in a multi-homing scenario, some of the node link failures, the ISSU, the in-service software upgrade, and how much time that will be allowed to the device to recover without breaking the control sessions. So by a small set of the data, we expect the user or the tester will take the high-level parameters and generate the configuration depending on the underlying device type. And what we all care about is get a set of the validation from both the resource, basically a set of the KPI, and the performance in the term of the forwarding, the scale of the control plane it can handle, as well as making sure they have demonstrated enough resiliency and meet those threshold for various types of the events. So this is there's a lot of work underway to make it really useful and make it more complete, so that it can be used to profile various types of networks. So I think the decision is really hard when we try to distill a large number of the existing YAN data model into a very small subset and only keep what's necessary. That's the hardest part of this proposal. Okay, next one. Yeah, go ahead.
Here's a question, Sean, from Al.
Sure. Okay.
It looks like most of the things we're looking at here, the elements of the Yang model, so to speak, many of them are provisioning or configuration values. Like, for example, we've got the traffic profile here, which would be both be input to the device under test, but also the input to the traffic generator to use these specific frame sizes. It would be good to distinguish between what appear to be the measured values over here on the right under forwarding as sort of less about, well, I guess all of these are potentially measurements here under resources, aren't they?
Yes, the resource is a snapshot of the current kind of load indication and also the final outcome of the, I guess, the results of the testing. Yes.
Good. And it may be worthwhile, just as a as a quick feedback that occurs to me here, that we've got these what we call sort of secondary or auxiliary metrics, like the CPU utilization and the memory footprint and so forth. Those are good to know, but we always set them aside from the benchmarks that we try to measure. The benchmarks, of course, like throughput, being the primary things that we're after. The CPU utilization at the measured throughput is a good thing to know, and probably the kind of information that we'll particularly want to supplement our benchmarks with, so that we've got a better chance of improving how our benchmarks are used in network engineering in the future.
Yeah, absolutely. I think there's a different level of the importance of the resource sections. And also, this is just showing one snapshot of the steady state. And also showing, we probably would be interested to include is a peak utilization. And utilization in event of those failure scenarios, how the network will respond. Because in a like say in intent-based networking, those utilization will matter and dynamically change the configuration back to the service provisioning, meaning they will dynamically move the component of a certain function into different elements within the network. So that's why I think it becomes more important over the time that both the forwarding and the snapshot of the resource utilization need to be captured as a single set.
Good.
Yeah.
Sean, I have a question. So I'm not sure if I'm clear based on what Al asked. Are there, under the resources profile, are you looking to set the values? Are you looking to say this is what you would expect as maximums? What is the intent of the resources configuration here?
Resource is not a configuration. Resource, it is a measurement, is a snapshot, but also we can provide some of the reference threshold, meaning that typically under this scenario that we expect the device to reach certain performance.
So then, just to clarify, you're saying that this would be populated at the end of a test or a test case run?
And it should, most of the value that should be captured and as a result of the test run. But in some cases, the resource could have a predefined threshold. That can be a more kind of the benchmarking, a common, for example, we expect that is the line rate throughput at 100%, but it may not reach to it. But most likely, the original intention, yes, like you mentioned, is capture the results, not necessarily prior to the test. It's a configuration. It's more kind of a dynamic snapshot.
All right, then, not to beat this up. So I see under your traffic mix, you're showing sort of classic picks from 2544. Are you accounting or allowing for iMix? And so you would just specify your non-standard, your iMix configuration here in some way, I guess?
So the frame size, the traffic profile is a way to provide a user to either pick a predefined, like RFC 2544 and a profile, or they can construct their own distribution based on the real network measurement to mimic the real environment. Here, not necessary to tell which one the user what value it is needed. It just provide a way that if they want to have a customized profile, those are the value they can provide, and the underlying processor of this model can generate the real traffic on the test emulator based on the limited set of the parameter from the user.
Thank you.
Sure.
Very good.
Okay.
All right.
Next slide.
Moving right along.
Okay. So here's a few use cases that I can think of how we can, if we spend the time develop those abstract model, how can we use? First of all, is to have a formal way to document the benchmarking methodology and the results in a more inter-exchangeable data format. And once a library of the source model or network deployment scenario is being developed or captured, so here's how I can see that being used. First of all, is a map between the real network, a production network, to the abstract model. We can have a set of a tool to discover the existing network utilization, existing network baseline, and to convert those actual configuration, probably is going to be a giant set of the data, into a simplified abstract model. Once we have the model, and we can feed back into the test lab for the benchmarking, for the design choices, and do the what-if scenarios. And finally, we have the test results and feed back to the model to document and to store the data for the further analysis. And those results, the results from those analysis can be further fed back into the network to improve the design, to optimize the resource assignment to those things. But what I hear on the lower right corner is really kind of a nutrition facts for a network. And this is to provide it's a really hard decision to which element is most important that we should be included those in the network facts sheet. I know there's a lot of data sheets out there. Typically that we have follow the benchmarking RFCs, and we already have a set of those. But I think when we move along and how we can define those key element information in the YAN data model and provide a more interchangeable format so that a user can use the same set of the syntax to generate the report they like. Okay, I think that's pretty much it. Next slide. So here's next step. Now, I definitely need some help from the more collaboration and provide the input various type areas, especially for the SDN area, how we can make this more compatible model to work with the virtualized network. And we need to validate the YAN keywords and making sure that we have to run the link for the YAN and create a sample detailed for complete profile for layer 2 network, or could be layer 3, just picking an example. And then all these feedback once we hear more, and we'll update the internet draft. That's all I have. Thank you.
Well, thank you, Sean. That was a great and very interesting presentation. It was our first exposure to Yang models here in the benchmarking methodology working group. And I think now we can probably say that the net confiscation of the IETF is complete. That's the term that people have thrown around for how the reason that everybody in the IETF seems to be working on a Yang model somewhere.
Yeah.
So we have a question at the microphone, and please identify yourself, sir, and ask away. Thank you.
I'm Pedro Martinez from NICT. My question is that how do you think to deal with data and actually the benchmarking stuff? You know, you have some kind of for benchmarking you must have some kind of algorithm and also some data to input into the protocol or whatever. and then some reference output to compare that. Where do you plan to find this data, and what, in that sense, how do you think that it will be done with your model?
Yeah, I think the model, thanks for the question, by the way, and I think you're definitely rightly point out the difference between the model itself and the data to be captured, and how the data can be used or analyzed for the further improvement of the network or benchmarking. So if I understand your question correctly, is that how can the data being used to reference maybe reference the what expectation, or how the data is going to be used to fed into this model? Maybe you can elaborate a little bit. I'm sorry.
No, sorry. More than that is which kind of data are you planning to use? What you proposing to use?
Okay.
You know what I mean?
So,
like real tracing data from the network or something similar?
So is the question in the context of this this slide here?
Yeah, you have in this slide, in the lower left, you have this design and benchmark that is provided to the test lab, where there you also need some kind of data to input to the whatever protocol software or whatever you are testing. Where is that data coming from? That's what I mean.
Okay.
So the question is that where this data is coming from to be fed into the test lab, so that the test lab can do their test, right?
Yeah.
Okay. So this is the trying to use a set of the a subset of the EM model. Take it for example, layer 3 VPN. Layer 3 VPN has so many arguments to completely define a layer 3 VPN offering. What this model does is to extract a subset of the key elements. For example, we only tell the test lab, I need have 100 sites. Say I need a total of the 100,000 routes, but not necessarily tell the test lab which router has how many routes, or which router has how many VPN instances. What the data is to provide is an aggregated view, so that a test generator will use this high-level data from basically is describing a customer requirements for a network, and then distribute it into the individual devices based on the definition. If we go back to one slide as an example, probably that can be explained better. Yeah.
Okay.
Yeah. So in this particular case is that this model defines what the key elements is needed to describe a network, a sufficient number of the elements, and the actual value is not set by this data. Instead, it should be set by the test engineer say, hey, this is the target. I have a bigger router. I need to increase the number of the global MAC count instead. The model only defines what to define, but doesn't define the actual value. I'm not sure if that answers your question.
That's okay.
So if it doesn't define the actual value, I think one of the sort of core tenets that we have in BMW, I feel like I'm Scott Bradner now.
Yeah, go ahead.
Repeatability. If it doesn't define the actual value, then how, if I run the same test 10 times in a row, for example, how do I know that I've run the same test 10 times in a row? Or how do I know I've run the same test with the same input values each time, so that I can compare apples to apples the results? Do you see what I mean?
Well, yes, but I think the value, when we do a report a test, say this is the described the profile. The profile will have a list of the elements and the value itself. But our proposal here is just to define the skeleton of the profile, but the repeated test will have used a set of parameters. They will use the same set of the number. They'll pass on the test generator. So out of the 10 attempts, they will use the same number. So I think there's a question is, does the profile contain the value? Yes, it does. Does our proposal define the value? It doesn't. Our proposal only defines the key elements, but certainly we can provide the values, but the value will change over the time depending on the capacity underlying network can offer. So I don't think I answered your question. Maybe.
So Sean, I think what you're saying is for the slide that Al has up right now,
Yep.
the profile itself is in essence the methodology. You just happen to provide in the example sample test data that the tester filled in. But I think what you're saying is it would be up to me to take the skeleton without the values, and then as the test case or the engineer, fill in the values and record exactly what I tested. And then, of course, I could repeat with those same values 10 times in a row, for example. Is that correct?
Right. Yes, that's correct.
I see. Okay. Thank you.
Sure.
Very good. Good clarification.
Yes.
So there's no one else at the microphone. Well, I think we've got a decent idea of what you plan here, Sean, and I think it will be. I've got your next step slide up.
Yep.
We should have the call for collaborators on the mailing list.
Yeah, absolutely.
And I think
looking for additional help, and if anyone is interested, the really goal is to provide a simplified kind of profile of the network, so that make our benchmarking easier and more interchangeable.
Right. And I encourage you to continue to flesh this out in terms of the Layer 2 network benchmarking example.
Okay, sure. All right.
Anything else, folks? Okay, very good.
Oh, thank you.
Well, thanks for your proposal and your presentation. Both very good and informative here. We'll see where the working group wants to go.
Okay.
Okay. All right. So next on the agenda here is the back-to-back frame benchmark proposal. It's obviously going to update RFC 2544. There's just one section of RFC 2544 which would be updated here. And so here we go. So the draft was prepared and circulated on the list. Made a little announcement of it, and as a little background for this proposal, RFC 2544 specifies this measurement, measures the back-to-back frame benchmark. That's what it's called, but it requires a little more. Really, the back-to-back frames is more a description of the methodology than it is what's actually being measured. It's defined in RFC 1242 as the longest burst of frames a device under test can process without loss. And they go on to explain that tests of this parameter are intended to determine the extent of data buffering in the device. So in 2544 today, there is in fact a very concise objectives expressed, a very concise procedure, and also a very concise reporting for this benchmark. It's about 5 paragraphs. So when I looked at this testing, in the context of testing V-switches in the OPNFV V-switch performance project. We made some measurements of this benchmark, and the results are basically shown in these two links here, two references. The reason I included the links was because in the printout of the RFC, something went wrong with the formatting, and the URLs went away, so it wasn't much help.
Oh, yeah, we don't know.
Well, it was. It looked to me like it was in a place where they would be displayed, but apparently you got to just append it in the title or something, and that makes it show up in the reference. So, so I've got that straightened out here for at least for a temporary basis. And as I said, I circulated and discussed our results from the V-switch performance benchmarking at some length at the last meeting. I'll talk about that a little bit now, but you're welcome to take a look at the slides, which are the this first link, and actually you can see even more detail spelled out in the this wiki page where we're working on lots of traffic generator testing and comparisons there. But looking at the back-to-back frame testing in particular. So, when I ran the tests, and this is as I said, this is a test where you've got the traffic generator sending traffic to a device under test, and it passes through the device under test. It's either routed or forwarded or encapsulated or transcoded or whatever else the device under test does to the traffic, it does it, and then it passes that traffic back out the other side for reception. So it had been noted in the past that the back-to-back frame benchmark had some problems with consistency, but we were able to test this over a series of months and actually over a series of two different hardware platforms, and we saw very consistent results between the two for fixed frame sizes. And it was somewhat variable in a few of them, but we came up with an explanation for that. But the sort of the surprising results were for large frame sizes. You saw the range of frame sizes that Sean just showed us, all the way up to fairly high values, 64, all the way up to 1500 approximately byte frames. But the frame length reported for large frame sizes was unexpectedly long. In other words, it was on the order of 30 seconds of storage in the device under test. We knew that wasn't true. And so it required us to investigate that. And the test equipment we were using didn't report any kind of error when it said, I just produced a burst of 30 packets, and that's as far as I'm going to go, and so that's the longest burst this can handle. It turns out that was erroneous data the test generator was reporting. I'll explain that a little bit later. The calculation of the extent of buffer time in the device under test helped explain the results with all frame sizes. It turns out that some frame sizes, like the highest frames, the device under test was able to process them at full back-to-back frame line rate. So, in fact, while the processing is bleeding off the buffer as fast as the frames arrive, you don't get the buffering that you're trying to measure in this test. Now, that's a problem if you don't report it that way. So that was one of the things we want to change, I think, about the procedure. And it was observed that the actual buffer time in the device under test could be estimated using the results of the throughput tests previously conducted based on RFC 2544. So that the final conclusion there is that the throughput test results actually, if they're paired up with the back-to-back frame test, they can also be used to reduce the number of frame sizes tested, because only when we have a frame size which is faster than the device under test can handle do we generate a queue length and eventually a a tail drop or a queue overflow, where the burst of packets that was submitted causes some loss, and then we can conclude that the burst was too long. So we have to reduce the burst size and then continue with the trials of the test. So you really want to distinguish those two cases where the packet sending rate with extremely large frames is too slow to create a queue, and those which will create loss. So we begin by expanding the back-to-back frames test method here. And so we have identified that the 2544 throughput test needs to be a prerequisite test now, absolutely conducted beforehand. So the test setup and configuration must match between the two tests. We're going to use the same recommended frame sizes, and we must be using the zero loss condition, which is what 2544 mandates for throughput. And then we can reduce the frame size set for back-to-back if we compare our delivered frames per second with the theoretical maximum, which is the green bar here in this case. So on this graph, and this comes from the OPNFV testing, we ran tests at 64 byte frames with the open V-switch. We saw, I guess it was about 24 million frames per second. With VPP, it was a little bit less in this particular test, but they were both less than the maximum theoretical throughput. So this is a frame size that we can test well to see if the device under test is going to be doing it. Well, it's certainly doing some buffering. It can't keep up. The device under test can't keep up with the maximum throughput at 64 bytes per second. So at 128, it's a little bit ambiguous. It's actually very close to the maximum theoretical throughput, and we'll actually see that in the results. But then at 256 or 512, there we get in both cases, both for VPP and OVS, they lined up exactly with the maximum theoretical throughput for frames at the minimum interframe gap. That's what back-to-back stands for. So what we can conclude from this graph is that most of our testing would be conducted using the 64 and the 128 byte frames. And there's no point really for this particular configuration to go on and to do 256 and the higher frame sizes. We're never going to see queuing, and so we're not really going to be able to measure the buffer size. So in the procedure, we would list the frame sizes selected for the throughput tests. The tests are composed of repeated trials. For each frame size, a trial requires sending a burst length counting the forwarded frames, and the trials seek to the trials seek the longest burst length that can be sent with zero loss measured, or same number of frames sent to the number received. And the test outcome is every time it's the burst length, and we're only going to count the ones where we see zero loss. So the tests are repeated n times, and actually after you seeked and found the largest burst that you can send without loss, then you record that, and then you go on and repeat the searching again. And so you do that n times, and the burst lengths are then averaged. And the average length from n repeated tests is the benchmark value. So that's a lot more detail than is currently in RFC 2544. But I think that that's the set of things that we are looking for now. So for clarifications, so I grabbed this right out of the draft. So for each frame size, we're going to calculate the following summary statistics for the back-to-back frames over the n tests. The average is the benchmark. but we're also going to report the maximum burst length that we saw in the end trials, the minimum, and the standard deviation. And further, we're going to calculate the implied device under test buffer time and the corrected device under test buffer time as follows. So the average buffer time is the average number of back-to-back frames divided by the theoretical frame rate. So what we've got here is a calculation of the time that that is represented by the burst, and that time is, it turns out it's both taken up in buffering and frames that were served by the processing, because the device is attempting to keep up with the maximum frame rate, but in the low packet sizes, it's not able to. So what we calculate this total time, but then we're able to correct this buffer time by figuring out the proportion of frames which were in the burst, which were actually served and processed and basically sent out of the device under test while the burst was running. So in fact, you can think of it as a buffer which in the implied buffer time, it's the complete burst. That buffer is the time is represented by all the packets sent in the burst. In this corrected buffer time, we use the maximum theoretical throughput to figure out how many packets were bled off the buffer before one packet overflowed. And this gives us an estimate of the actual buffering time inside the device. So we would report the results as follows. For a given frame size, like 64 frame octets, we would report our average back-to-back frame length at the burst. Here it's only 26,000. So that's a good point. I'll probably want to boost that up so that it matches more the kind of millions of packets we've seen in typical testing. But so we've got the average at 26,000. We've got the min and the max and the standard deviation here reported at 25,500, 27,000, and 20 packets. And then the corrected buffer time, which is let's see here. It looks like that's about, it's small. It's 40 microseconds. Yeah, so not very much. So that would typically be reported in a table like this. And in addition, we'd want to report the standard, the static and configuration parameters that are associated with the test. So that's the number of repetitions, obviously, and the minimum step size that the device, the tester uses to try to determine the burst length. In other words, it may not be incrementing the burst length by one packet. That might take a very long time. So that might be configured at in a test where we're trying to test millions of packets. We might have a step size of 100 packets, let's say, something along those lines, and that would improve our ability to complete this test quickly. So this is so a lot of this, other than the average, this is a lot of new information that we're requesting. Now we've kept the traditional average benchmark, but we're asking to add this additional collateral information. Please sign the blue sheet, sir. You've been here for 10 milliseconds. Too late. So, so that'll give you a feeling for the. Oh, I think the blue sheets are right. It's right here. You're right here.
Thank you.
Very good. Thank you, Stephen. And welcome to BMWG. So next steps. No one, as far as I can tell, no one's actually read and reviewed the draft yet, and that would be essential before we adopted it. I think. I have to hold myself up to the same standard that anyone else would as a participant bringing a proposal here.
I'll
of course.
hold you there. You're good.
And then, so once we get some readership and review and feedback, we could possibly consider. I guess I really didn't ask the room. Has anyone read the draft? That looks like a real light turnout.
Who will read the draft?
Yeah, who's willing to do some work here? Great. That's the kind of commitment we're looking to see. So thank you for that. Great. In fact, you can start reading it now.
No, we have rechartering.
Well, I know. So, but we could agree to create a milestone for this work if on the basis of this description today that we think this is worthwhile. I've actually proposed one there, and then obviously sometime in the future after we've done some readership and review, but we'll hold off on asking that today. We'd ask for a working group. This whole list of authors, me and actually my colleagues from OPNFV vSwitch Performance Project may join me on this author list as well. But I wrote this in like 2 days over the weekend, so I did get a chance to ask them if they wanted to join it. But in any case, there's no guarantee, even if we take up a milestone, there's no guarantee that this draft would be the one that satisfies it. Other ideas are welcome. So that's the way we play here. So, Sarah.
So I'll ask, please, that we read the draft, and I think we'll come back to your suggestions there, Al, in London.
Very good. We should ask if there's any questions or comments in any case. And I want to do that because I saw you coming to the mic.
May I ask?
Please say your name, too.
Sorry, Barack from Mellanox.
Barack, nice to meet you.
May I ask, what is the thing that you are looking to test using this methodology? I will detail a little bit. So when we do these kind of tests, usually we are looking to test some particular component within the switch architecture, such as queuing, such as packet processing, such as buffering after processing or before processing. My takeaway from what you described is, in a way, you try to check what is the capacity to buffer packets before processing happens. Am I correct, or can you clarify a little bit more, please?
Stay right there. You may have a follow-up question. What I anticipate is that I've in my mind and the way I described it, I modeled this as one buffer and one processing stage that bleeds off the buffer. The reality is there are many more than one buffer, and there are many processing stages, but at least one of them is the bottleneck. So what we might see is the sum of all buffers up to the processing bottleneck, and then queuing bleeds up or grows out to the ingress interface before that.
Right. So let me try to say it in my words. So you're trying to check how much buffering can happen before packet processing cause these issues.
Before the limiting packet processing, I guess that's right.
Yeah.
Thank you for that.
Good.
Because just as a note, usually we use these type of things also to detect how much burst absorption in terms of congestion a buffer can absorb, which may result in totally different results and places within the switches that take into consideration.
I've been thinking that the reason to have this correction factor, to actually try to assess the actual buffer time or space that's available, is that, actually one of the background things is that real traffic doesn't necessarily arrive smoothly or continuously. It arrives in bursts, and it may be valuable to know when a device that's doing forwarding or routing, when that device pauses for a moment or two and the processing stops, then how much real buffer is inside that we can count on to be able to smooth out these bursts. So that's I think we're in sync on that.
Thank you for that.
Yeah, good, okay. Please.
Yeah, so my name is Wang Bongli from ETRI actually. So
Ah.
I asking about
Welcome.
it's work proposal summary metrics about previous slide. I mean the work proposal summary metrics. There is the work area, some six or seven things, but this is currently work area, right?
Are you looking at the? Oh yes, yeah. You're going
yeah.
back to the back to the
Yeah.
chairman's slides.
Chairman's slide.
Do you want me to put that up so everyone else can see it here while you're asking the question? Okay.
Is it okay? It's
Yeah. Oh, sure. No problem.
uh,
What the heck happened here? There it is. Okay. Yes, please.
what about the virtualized platform? I understand that, but what about the virtualization platforms? Is it the scope of this chapter?
No.
No.
It's a different draft that was prepared by Samuel Camus and Jacob Rapp. One that we discussed in our meeting in Chicago. It's sort of data center focused. It's a follow-on piece of work to the sort of the physical device data center benchmarking that we completed just in the interim period. But they are now beginning to look at the data center with virtualized networking as well. So that's the platform that they're talking about. I'm sorry for the shortness of the name there, but I can give you a link to that draft if you're interested in taking a look.
Yeah, so actually I'm interested in just like the packet accelerating techniques such as DPDK.
Oh yes.
Yeah, so I just wonder how the
Get closer to the microphone there. I think otherwise we're going to lose you.
benchmarking methodology about those technologies. I just want to create the new proposal probably next in this working group.
Okay.
So I would be very interested. In fact, I've been looking at potentially doing something down this path as well. So if you have that draft, as soon as you have that ready, with my chair hat on, I think we very much encourage that. It's very relevant to what we see in the industry, and how to benchmark that, I think, is a good thing. And then with my chair hat off, just as a participant, I'm very excited to read that. So if you're going to take that on, thank you. We'll see you in London. And please submit the draft before London so we have a chance to read it, and then we can talk about it in the next IETF.
Yeah, and I threw the email.
Of course.
Email list.
Very, very good. And be sure that you take a look at RFC 8204, which is where the Open Platform for NFV vSwitch project provided some considerations for doing exactly this work. I mean, that's the project that also contributed the test results that we just discussed. And so we've been testing vSwitches and now the Cisco VPP virtual packet processor there as well. So there's some possibilities for cross insemination of ideas and testing in this virtual switch and DPDK accelerated space. In fact, we're basically testing the plain vanilla OVS, the DPDK accelerated one, and VPP. And VPP uses DPDK as well. So thanks for your proposal. That's interesting. In fact, in general, the RFC 8172 talks about considerations for benchmarking in general in this virtual space, and we expanded on that here for virtual switches in this one. So that's another RFC that was published really just before this interim period. So it's actually been 5 very recent ones that we completed. Okay. So I think now we want to go to it's the the next generation firewalls. In fact, that's what we.
That's right. the question mark.
Right. Look at this. You can't.
Oh, I see. We skipped an agenda. We're really organized.
Yeah. Yeah. Let me see if I can. No, I can't do anything. This is. Yeah, this is really annoying. Oh, wait a minute. I can get rid of this at least. Okay. All right. So I've been asked to represent this proposal on benchmarking next generation firewalls by the proponents, who happen to be a couple of good guys who've worked with us here in the past, Karsten Rosenhovel and Balaraja, both from the European Advanced Network Test Center. And they're currently working with a not-for-profit initiative called NetSec Open. It's been formed to innovate network security test methodologies, and they've been looking at this for quite a while. They want to strongly improve the applicability and reproducibility and transparency of benchmarks for next-generation firewalls, but also intrusion detection and prevention systems, unified threat management, and I guess it's unified threat management solutions. So this is very opportune that we have such an esteemed security area colleague here with us as we're discussing this. Yes, he has to wake up now. Yes. So they're currently developing test terminology and traffic profiles, and they're focusing on the next generation firewalls first. And that's the work that they would like to begin to contribute here in BMWG. So they plan to put this, these other things on the back burner for now, and see how it goes with the benchmarking methodology working group. But they tell me personally that they looked over many different standards bodies to consider where to take this work and to standardize it, and they ended up choosing us for our ability to take up work quickly here. Also the good timing with our charter, rechartering efforts and so forth, and the fact that we have the attention of the industry here in having done this work before. RFC 3511 is our previous effort in this area. So they plan to submit their first draft sometime next week, and they hope to proceed quickly through November and December. And so depending on how quickly we want to review this work, we may take up an interim meeting, perhaps in December. We actually tried to have a nighttime meeting scheduled here when some of the folks from the U.S. who are part of NetSec Open could join us, but that didn't work out. Turns out that's actually not very easy to do. So we'll investigate the possibility of an interim meeting. It will be a virtual meeting to hear more from the NetSec Open folks. And what they've got here is a table of contents, which mostly is composed of the scope. So it's focused on test methodology for network security device benchmarking tests in terms of performance metrics. Describes the test methodology to obtain repeatable results independently using different vendor test equipment. By defining the full set of test configuration parameters, this document will allow users to reproduce network performance and compare measurements. Benchmarking tests focus on a set of key performance indicators. We're all familiar with those. Devices such as firewalls, next generation firewalls, intrusion detection and prevention devices. Well, see, this here they seem to go beyond the next generation firewall scope. So that's something I would feed back. I mean, I think they should probably attack next generation firewalls first, see how that goes, which is actually what they said in the message, and then worry about this this other interesting stuff like deep packet inspection devices, web application firewalls, and so forth. But I think we might consider adding a sentence in our charter to be sure that everyone knows that we're we're willing to take on devices in this ilk, if in fact the working group is. So let me ask the room now that we've described this. How is there any interest in helping NetSec Open here with benchmarking modern firewalls? If so, you can sort of raise your hands. Okay, nobody here today.
I mean, we're interested. Personally, a lot of my work stems from the company that I work for, and we don't manufacture modern firewalls, but certainly I think it's of interest, very relevant, to the industry today.
Absolutely, and when you look at the fact that in fact RFC 3511 was one of the first ones I helped to finish up as a co-chair, and so that's a long time ago, 2003.
Wow.
So yeah, a lot has been learned in the meantime. And if you remember, we had Mike Hamilton's content-aware work. Yes. Well, he was the original proposer. That's why I always think of him there. But if there's anything we learned from that work, we need to bring that forward as well. That's still relevant, of course. That's been retired for a few years.
Yep.
So and then the rest of this is fairly usual. The test setup,
Yep.
test bed calibration. That's a good thing, though, and reporting, and benchmarking tests and so forth. And they want to define traffic mixes here, both the stateful and stateless stuff. That's going to be interesting, but that's something they feel very strongly about. It has to be reproduced and used by all the vendors, the same mix.
I think that's, if you want an apples to apples comparison, that's key.
Yeah.
And I think it's one of the places where, at least for me, 2544 is great, but the average packet size has evolved on the internet from when we started out in 2544 times. So for them to at least take a stab at defining traffic mixes that make sense to them, so you can have an apples to apples comparison across vendors, isn't that what we all want?
Yeah, well, that and I think we want to continue with the fixed size testing as well.
Of course,
Yes,
so not
yeah.
to discount,
Right.
but I think we have that covered. So the mix is interesting.
And I've seen a couple of data sheets recently for devices in the next generation firewall class, and they are basically testing whatever they want at the moment. So that's the goal here, is to get everybody testing the same thing, so that we can have the apples to apples comparison without the specmanship.
Yeah.
That's our original goal. Okay. So any further questions about that? I encourage you to visit the NetSec Open site and see what else they've got going. But I think that's a timely proposal, and one we should consider further, especially after we've seen the first draft of their draft.
Yeah.
Okay. Well, thanks for participating in that review. I guess I can get rid of that now. And so back to the agenda. So we've covered everything here that we planned today, except for the sort of the discussion of any new proposals and the rechartering discussion. So I would like to now open the microphone to any new proposals that folks would like to make, although we did hear one along the way. And since I don't see anyone rushing to the microphone, I thought that I would make one myself. In fact, during the IRTF Open session, Mr. Paul Emmerich from Technical University of München talked about the München traffic generator, and also some results that we've some of us have seen in the industry, where if you use a different traffic generator, and there's quite a few choices out there today. There's the hardware ones from Ixia and Spirent, and of course several software generators like Moongen, and also T-Rex, which has its own platform but can be run on general purpose hardware as well. And there's a few others. I won't try to mention them all. But the point is that we've seen some sensitivity of the results to the sensitivity is to the generator itself. And we suspect that that's due to the characteristics of the packet streams that the generators are in fact generating. That they may be generating bursts when they say that they're intending to generate a constant bit rate stream. Also, we might recognize that more of the traffic in the network today is bursty than CBR. So maybe some of our streams that we generate should have some burst characteristics as well. But the idea that came to me as Paul was making his presentation, showing the stream generator characteristics, was that if we have ideal characteristics that we're trying to match, that a measurement of the stream itself would be very valuable, and we could compare that with a tolerance template around let's say the inner packet arrival times that have been generated. Compare that across a stream that's long enough to characterize a device under test, and then for every generator that we're considering using in the various circumstances and so forth, take a look at how well it conforms to this template of tolerance, kind of as a calibration of the generators themselves. And I think that if we wanted to take up this work, that we would need to add at least one sentence to our charter to say that we will also look into this calibration. Excuse me. So what do you think, Sarah?
I think the idea of having a test topology where your traditional DUT in the middle is not actually the DUT, but rather the test tool itself is the DUT is a fantastically wild idea. I'm not entirely sure we'll make friends with some folks who have visited us in the past, but particularly as we take on virtual... Are you okay? Okay. I think as we take on more of the virtual testing and how do we, particularly with some of the results that Al's presented from the OPNFV work that we've done, as you start testing, there's a lot of push for not just physical testers where you have a PNIC involved, but virtual testers where the traffic stays inside of the virtual machine. And I know there's a lot of controversy around that and how do we make sure it's a black box test, but the idea of having the ability to test the test tools, I think, is something that we've seen, or I've seen as an equipment manufacturer coming in for my customers. So has anybody else had experience with this? No answers. You're going to be buying beer tonight at Pecha Kucha, just letting you know.
So, Paul Emmerich, TU Munich. So, yes, obviously I've had experience with that since I gave the talk earlier today.
Oh,
and it's really difficult to measure. So this is like everything's moving to software packet generators. And now we are seeing that they are not accurate. But again, to validate them, validate the software packet generator with another software tool doesn't really work because you get the same your measurement device, the same position problems as with your generation device. And so you then really need hardware to precisely calibrate it. Then the next question is, what is an important, or what's the right metric to, or what's the right tolerance? What is even acceptable? Maybe some small bursts are acceptable. Maybe this is even what we want. So I don't have all the answers. I just did some work there, and it was very, very challenging. And also, yeah, the results were kind of unexpected. I thought we might find some small deviation, but then we found that the latency differs by 400% just because we changed the burst size. And it was like, oh, what is going on?
So could I then, I agree. I think it's hard. I do think sometimes when we take on a draft, we take it in and it doesn't have to necessarily publish out. So if we get to the end of the exercise, maybe we decide this is too difficult to do, but at least we tried. For me, I think it's valid. I wouldn't mind. I had a class today and couldn't see your presentation, and I'm wondering if I could potentially convince you, if we have time on the agenda in London, to present it here.
Sure.
And then we could maybe ask a second time, do we want to contribute, or would we want to look into this?
Sure, that sounds like a great idea.
Thank you.
In fact, I'm sure your slides will be available in the IETF Open
Yes, they
agenda,
should be.
so we can take a look at those.
Yep.
But yes, absolutely. I think if we can pursue this, then that would be great. I'd be very interested in following up on this as well, Paul. So
yep, great.
I think the minute anyone in the test generator world gets wind of us thinking about doing this, we'll suddenly have lots of collaborators.
That's a good thing, though, right?
That's right. No,
Also
that's
something
absolutely
that I wanted to look into, as whether the hardware packet generators are actually as precise as they claim, and this I didn't have any on hand. So
maybe that's it. Maybe the first draft that we take on focuses on hardware, and if we can get collaborators from the other vendors who have traditionally come into BMWG, I think this becomes a little easier. We can donate a WebEx and talk it through and run our tests, and then bring results here.
That would be really nice. So how I did these tests when I did them, we used the net FPGA, but that was like, well, it's great hardware, but it can be very cumbersome to work with if you need to change something.
Sure.
But at least you build the hardware yourself, so you know it works.
And if we have actually, there's no reason to wait all the way for London. You've got the slides, and if we have an interim meeting, this could be one of the topics that we take up.
Sure.
But you could still potentially get a trip to London out of this.
Yes.
That'd be good. So okay. Well, I'm glad I brought that one up, and it was well timed with Paul's earlier presentation. I think that's a potential thing that we would want to add at least one sentence in our draft charter. So at least there seems to be interest in it, right, Sarah? Mm-hmm. Okay. I wonder if I can. Let's see here. I was just going to try to. Oh yeah, I've got it right here. All right. So I wanted to mention that we've got this charter that I shared on the list for discussion. Sarah and I worked on this a bit before it was republished, and this paragraph here, the scope of BMWG, has been extended to develop methods for virtual network functions and their unique supporting infrastructure, such as SDN controllers and vSwitches. So we had this as a kind of like a bullet item before for a specific area of work. We've actually completed the considerations draft, which was the first homework item there, and we're just about to complete the SDN controller stuff and go on and do some other things. So we've got all sorts of things here mentioned: platform capacity and performance characteristics of virtual routers, firewalls, signaling control gateways, and other forms of gateways are included. Benchmarks will foster comparison between physical and virtual network functions, and also cover unique features of the network function virtualization systems, like migration or lifecycle operations and so forth. There's plenty of things that we could be doing which are not data plane things.
Correct.
Lots of stuff. So I think just as a note to self, I actually think we've got enough here to support the, well, maybe not quite enough here to support the security-related things that came up.
So there were two bullets we talked about adding. One was
Yeah.
for the security, and the second was specifically adding a sentence for the calibration
Right.
devices. So let's make sure we add that in.
All right. What happened there? All right. So security devices and calibration.
Yes.
I'm going to say test. Device. Okay. So we'll flesh the wording of those sentences out and circulate it on the list. And then I guess we'll propose, after we've had some time for review and some of the other documents, we'll propose milestones related to EVPN and whatever else we decide to take up out of the set of new proposals. We've heard about 3 brand new proposals today. We've got some other ones which we've shown in the matrix there lurking around, and hopefully the proponents will be more active. And then we should have a good set of milestones that we can put together with our charter text and go to the IESG and say, please let us continue as one of the longest running working groups in the IETF.
Yeah.
Shouldn't be too much problem. All right. So with that, we've got a plan to continue with our rechartering activities. We'll let Warren know about that as soon as we can.
Yep.
And then I think we've now reached the any other business topic. So if you have questions in general, ideas about benchmarking, now's the time to come to the microphone and talk about it. Okay, looks like a pretty satisfied group. All right, folks. Well, thank you all for your attendance and your participation, in particular, those who did. I think that we were very glad to have that here today. And there will be even more of us in future meetings, I can guarantee you that, where we've really started to work out our details for new things. In particular, we'd like to thank Sean Wu, who participated at a very early hour in the East Coast of North America. Thank you, Sean.
Thank you for the opportunity
And,
to join.
Yeah, it worked very well, and we're very thankful to MITECO for that. So thank you, MITECO guys. And so there we are. I think we're done, folks. So thank you again, and we'll see you in most likely in a virtual meeting, interim meeting, but also for sure in London. Thanks again. Sorry, we need the number.